Moving an entire enterprise from physical, on-premises private branch exchange servers to cloud-based unified communications requires an entirely new architectural strategy. Microsoft Teams operates as an enterprise-grade unified communications platform, consolidating telephony, messaging, and video conferencing into a single managed interface. But deploying Teams Phone at scale is far more complex than simply turning on a dial tone. It requires navigating a dense matrix of infrastructural, financial, and regulatory choices. To pull this off, enterprise architects must master three specific layers: establishing external PSTN connectivity, selecting the correct hardware endpoint ecosystems, and integrating contact center routing. We are going to map out the exact Microsoft Teams unified communications architecture required to construct a secure, E911-compliant enterprise voice network. Transitioning to Teams Phone dictates the underlying physical infrastructure of your network, determines how you govern sensitive corporate data, and defines exactly how you execute your external customer engagement strategies. By default, Teams natively handles internal voice-over IP calls between users in the same tenant. However, enabling external calling to the global public switched telephone network requires organizations to select from a strict suite of connectivity models. The foundational requirement for any of these models is the Teams Phone Standard license. Depending on whether your users sit on premium E5 suites or lower-tier E3 licenses, this base requirement dictates your entire baseline economic model. At one end of the architectural spectrum, prioritizing maximum operational simplicity, is the Microsoft Calling Plans model. Under this model, Microsoft operates entirely as your telecommunications carrier. The organization purchases phone numbers, minutes, and the associated cloud routing directly from Microsoft, presenting a pure software-as-a-service deployment. That simplicity comes with severe limitations. Organizations are restricted to standardized configurations, stripping away architectural flexibility. Furthermore, the strict per-user pricing model quickly becomes cost-prohibitive for large enterprises generating high call volumes. The opposite extreme is direct routing, the industry standard for environments requiring maximum customization, global geographic reach, and heavy legacy hardware integration. Direct routing requires the organization to connect the Teams environment to a third-party carrier using a specialized, certified piece of hardware or virtual software called a Session Border Controller, or SBC. Because organizations control this SBC bridge, they can negotiate carrier rates and seamlessly integrate legacy PBX systems into the modern cloud. This also unlocks media bypass. Voice media flows directly between the local SBC and the Teams client, skipping Microsoft's processors entirely to heavily reduce latency. Sitting directly between the rigidity of calling plans and the technical heavy lifting of direct routing is a third option, Operator Connect. Operator Connect completely eliminates the need for internal IT teams to deploy and manage low-level voice infrastructure, SBC certificates, or complex FQDN and DNS configurations. Instead, the organization selects a certified third-party operator from within the Teams Admin Center. That chosen operator retains full ownership and responsibility for the voice network, managing the SBCs through highly resilient direct peering relationships directly into Microsoft's cloud. This 3D coordinate system graphs out the exact trade-offs of the three primary architectures, plotting calling plans, Operator Connect, and direct routing against their respective levels of control, complexity, and operational cost. Securing the appropriate PSTN connectivity model early in the design phase dictates the physical hardware footprint, strain on internal IT resources, and the long-term financial structure. With the cloud routing established, the architecture must then address the physical hardware ecosystem. This is bifurcated into native Teams certified endpoints and legacy SIP devices. The native Microsoft Teams Rooms ecosystem relies on embedded, strictly certified hardware. Capital expenditure scales rapidly here based on physical room complexity, jumping from 8,000 reals for a small huddle space up to 150,000 reals for a fully integrated premium boardroom. For organizations unwilling or unable to replace every existing phone, Microsoft mandates the use of the Teams SIP gateway to integrate non-native legacy hardware. The SIP gateway is a cloud-based service explicitly designed to preserve massive existing hardware investments. It allows organizations to deploy low-cost basic telephony for retail floors, manufacturing plants, or part-time staff, without purchasing premium native devices. Crucially, the SIP gateway provides vital support for robust digital enhanced cordless telecommunications, or DECT, networks. These systems are an absolute necessity in industrial and healthcare environments, where structural interference makes Wi-Fi roaming dangerously unreliable. This comparison table details the precise capabilities of native devices versus the SIP gateway, showing exactly what is sacrificed. SIP devices handle inbound and outbound calling, but critically lack video calling, proximity join, Active Directory search, and Bluetooth PC integration. While the SIP gateway effectively preserves legacy hardware budgets and solves immediate factory floor connectivity issues, it deliberately limits the unified communications experience for the end user. For environments handling high-volume customer interactions, the native Teams call queues and auto attendants fail to provide the advanced, omni-channel skills-based routing required by modern enterprises. To solve this, Microsoft operates a certification program for third-party contact center as a service providers, highly mature and functional, but physically disconnected from the most modern native capabilities. In the Connect model, vendors handle all routing and media processing on their proprietary infrastructure. The audio stream physically hairpins outside the secure Microsoft boundary. This external routing introduces potential latency, voice quality degradation, and complex security and compliance monitoring. A secondary tier, the Extend model, improves the agent experience by embedding the contact center interface directly inside the Teams client, though the underlying telephony logic still depends on the external vendor's infrastructure. The Unify model represents the highest tier of technical integration, built natively upon the Azure core. The Unify model does not rely on external telephony infrastructure. The contact center is built natively inside Microsoft Azure, using Azure Communication Services. Because voice traffic never leaves the Microsoft cloud, organizations achieve ultra-low latency, strict data sovereignty, and a single native telephony platform. Native access to Azure Media Streams enables Microsoft Copilot to perform real-time transcription and sentiment analysis within the communication flow without routing to third-party servers. When deploying enterprise contact centers, the architectural proximity of the media stream to the Azure core directly dictates the speed, security, and effectiveness of your artificial intelligence injection. None of these cloud routing models matter if the local network fails. Real-time cloud media will collapse into robotic, dropped audio without strict quality of service, or QoS, packet tagging applied across the corporate WAN. To guarantee performance, the physical and logical network must hold firm thresholds. Round-trip latency must stay entirely under 100 milliseconds, and jitter must remain under 30 milliseconds. But ensuring clear audio is secondary to the most critical legal challenge of cloud voice: maintaining emergency calling compliance across a highly decentralized mobile architecture. Regulations like Ray-Bombs Act in the United States legally mandate that a highly specific dispatchable location, down to the exact floor, suite, or quadrant of a building, be transmitted to dispatchers with every single emergency call. When a 911 call is placed, the Teams client dynamically reads network telemetry, like the Wi-Fi MAC address, to find the user. The Location Information Service correlates this to a civic address, mapping it to SBC routing tables to securely transmit the exact location to dispatchers. Maintaining this LIS topology mapping is an ongoing, non-negotiable operational imperative. Routine network changes that are not synchronously updated in the LIS will silently break emergency location routing, triggering severe legal liability and financial penalties. Beyond emergency routing, adopting Teams creates massive, immediate repositories of corporate data. Unlike consumer applications, enterprise chat and channel messages are subject to strict public inquiries and freedom of information requests. We can see this exact dynamic playing out during the Scottish Government's COVID-19 public inquiries, where digital communications policies faced intense legal scrutiny. Upon transitioning to Microsoft Teams, the government recognized that the sheer volume of digital communication represented a massive compliance risk. To manage it, they deployed automated information governance and retention policies across the entire system. The specific mechanics were ruthless. The system initiated automatic, unrecoverable deletion of standard Teams chat messages after just 5 days. It became the strict responsibility of the individual user to manually extract conversations containing business value or legal evidence into official corporate record systems before the clock ran out. Unified communications in the cloud removes the burden of physical hardware maintenance, but it replaces it with strict, unyielding enterprise mandates for network resilience and corporate legal compliance. A truly highly functional Microsoft Teams environment does not optimize one architectural layer at the expense of another. Enterprise architects must calculate the exact tipping point where the operational ease of Operator Connect outweighs the granular, legacy-compatible control offered by direct routing. They must strategically dictate when to preserve legacy SIP hardware on the factory floor and when to mandate the upgrade to native Azure architectures to unlock the speed of the unified contact center model and Microsoft Copilot. By synchronizing licensing economics, prioritizing Azure native routing, and strictly managing E911 and data governance frameworks, organizations can successfully transform their outdated PBX environments into highly agile, secure, and fully resilient unified communications platforms.